The first topic for Unit 4 that we're going to look at is symmetry. So when we talk about symmetry, we have three different types. We have line symmetry, point symmetry, and rotational symmetry. Line symmetry is when we have a figure, so a shape, a letter, anything like that, and we are cutting it down the middle and the reflection is the same on both sides. So it's sort of like using a mirror and we have the same thing. That's line symmetry. Point symmetry is if we have a point on our figure and we can rotate our figure 180 degrees to get the same shape. So the easiest trick is to think about if it looks the same upside down instead of having to turn the paper. The last point is our rotational symmetry. With rotational symmetry, we have that if the figure can be mapped onto itself by rotating, but it's less than 360 degrees. So a full 360 would get us a circle, and this is if we're doing anything less than 360. And it has a center point. So if we look at our picture on the side, we have that center point in the middle of our sun, and if we turn that, we can keep replicating it. So as long as we take this top point and turn it to the next thing, we can get it. If we look at a few examples, for example number 1, we have a hexagon. Remember, a hexagon has 6 sides, and we want to figure out what kind of symmetry it has. If I look, I can cut my hexagon down the middle, and the reflection would be the same on both sides. So that means we're going to have line symmetry. We also have point symmetry because I can mark my center point and I can do a full 180 rotation to get the same shape back. It's the same thing upside down. We also have our rotational symmetry. So since a hexagon has 6 even sides, if I rotate my top side to the left, I can get my same shape. If I rotate it again, I get the same shape. If I rotate it again, I get the same shape. So all of those sides will match up. If we look at our triangle, again, if we cut it right down the middle, sort of like our example up here, we still get an even reflection on both sides. So that means we're going to have our line symmetry. We don't have point symmetry for this one. That's because if I mark a point in the middle of my triangle, I have a pointed side at the top and a flat side at the bottom. That means if I rotate it 180 degrees, it's not going to match perfectly back onto my triangle. We do have rotational symmetry though, because I can rotate each side of my triangle and still map it onto itself. When we say map it onto itself, that just means we're putting our shape exactly perfectly on top of itself. Some more examples. So we have a parallelogram for number 3. If we look at number 3, if I cut it down the middle, my reflection is not the same. So we do not have line symmetry. We do have point symmetry though, because we can rotate it and flip it 180 degrees and get the same thing. And we also have our rotational symmetry. So again, we can rotate it and map it back onto itself. Number 4, I can't cut it down the middle. There's no reflection. If I do a point, since this is a right triangle, again, I can't map it onto itself. And same thing with my rotational. If I try and rotate it in its center, there is no way to get it back to itself with anything less than 360 degrees. So this is an example of none. The triangle we were looking at before was an equilateral triangle. That's why we had line and rotational symmetry. With our right triangle, we don't have any of those things. For number 5, with our star, we have line symmetry and we have rotational symmetry. So we can keep rotating our point around and we can get that same star. Number 6 is a weird little doodle, but we can still see if we have line symmetry, rotational symmetry, or point symmetry. If we do our line, we don't get a perfect reflection, but we do have point and rotational symmetry. So using the point that they marked in our picture, we can rotate it a full 180 degrees and get that same shape back. And again, we can rotate it and map it onto itself. Looking at our symmetry also works for letters. So with the letter A, we would say that we have a line symmetry. It's cutting it right down the middle, but we don't have anything else. Number 8 is a lightning bolt type of thing. So if we look at that, we can't say that we have line symmetry. We can't say that we have point symmetry, and we can't say that we have rotational symmetry. So that's going to be an example of none. We have a few more examples, and I'm just going to go ahead and show you the answers for those. I do want to point out that we have a variety of different ways that we can answer these. So when I say that, that means some of them have all three of our symmetry. Some of them have just point and rotational. It is possible to have rotational without point symmetry. Some are just line, and some are none. So we have to make sure that we're checking each and every option when we're going through these. Again, a couple more examples and I will show you those answers. When you're doing these and looking at them, I highly suggest being able to draw or write out some stuff. You can always put a point on your computer with that to see if it would work for rotational or point symmetry, and you can use your mouse to do an imaginary line. For number 18, if we did a vertical line, that would not work, but we can do a horizontal line to get line symmetry. So our line doesn't always have to be up and down, it's whatever line could work to get a perfect reflection. Notice that with number 16, even if I did my horizontal line as a line of symmetry, that still wouldn't work because the face and the hearts are on opposite sides. So we have a couple of different ways, but again, that is looking at our line symmetry, point symmetry, and rotational symmetry.